So what's voltage optimization? Okay, voltage optimization. Voltage optimization is a technology which basically reduces the voltage without increasing the current. That is important because reducing the voltage and increasing the current doesn't do much. But what we do, we try, and I do emphasize the word try, we try to solve problems that have been created because of the way the national grid in every country has been designed. So if you take any country in the world, you have the grid, which uses the smallest cables in order to transfer the highest voltage. And the reason they transfer this highest voltage is because you have small cable infrastructure. And there are rules. For example, in the USA, your rules is to operate at, in the three-phase voltage, 480 volts, but you get an average of 493. And your equipment could work down to 414 volts and 516 volts. So all the manufacturers will design equipment to run on specific parameters. And it's every equipment. For example, your car will be designed to operate at its most efficient at 56 miles an hour. Yeah. Your equipment has been designed to operate at they are more efficient at 460 volts, your motors, for example. Most of the equipment have design characteristics. So what we try and do is to get the voltage to the design characteristics of your equipment. So we reduce the losses in the system and therefore you save energy. Yeah? So that's the very, very basic idea of the system that we do. So in basic terms, we take the voltage, we clean it. We clean it for harmonics, electrical noise for the non-engineers. We remove some of the transient events, spikes for the non-electrical engineers. And then we reduce it and control it. Okay? So that's the very basic thing. So by doing all that, you save dollars, you save the equipment from damage, so you extend the life expectancy of the equipment significantly, and we have some case studies with some universities for that. And you run your equipment at their optimum performance. So it doesn't matter what equipment you have. You may have chillers, you may have UPS systems, you may have lights, motors, IT equipment, anything. Those equipment will have an optimum performance. For example, if you have a very efficient car and you travel, I don't know if you know the smart car, you know, okay? If you have the smart car and you travel from New York to San Francisco at 7,000 revs to get there very quickly, you will use more energy than a Hammer, or more petrol than a Hammer. And the reason is because it hasn't been designed to operate at 7,000 revs. It's been designed as a city car. So design is important. Running equipment at their design characteristics is important. So that is exactly what we do. We run the equipment at their design characteristics.